Okay, so welcome to the final video in the RAG series. And today we are going to understand what are all the different common problems that we are going to face when we are building a RAG. In the previous video, we have built a very basic backend of a RAG, and it's very extremely basic, I would say. If you take up any production level application or web applications that are out there for the users, they are 10 times more powerful than what we have just built. The components that you are using here, they have to be enhanced. That's the only difference. Instead of using PyPDF, we have to use document intelligence. Instead of plain chunking, we have to chunk using all the different five features that I've explained: semantic parsing, the tables, graphs, images, etc., entities, summaries. So in that way, you need to take a look at each of those step, and you have to enhance it to make sure that your RAG is more and more robust. But in that process, we will face many different problems. So let's try to understand what are all the different problems that you'll face, and why or how exactly can you say that this RAG is not the most powerful. So the very first place that you have to look at is what is the chunking strategy that you have applied. So how exactly are you chunking? What is the size that you have used? The chunk size and the chunk overlap, they play a very important role, because let's say if you have a very long document, and if your chunk size is 15,000, 8,000, 20,000, it will definitely give you lots and lots of hallucination, because you're passing a lot of information to answer a simple question, one small question. The relevant content could be just a single line in the 20,000 lines that you're sending. So your chunking strategy has to be very clearly defined. At the same time, if your chunk size is very small, and if your question can be answered using 7 or 8 chunks, but if your top K is 3, you are missing information. In that situation also, your LLM model will not be able to answer it properly. So your chunking strategy has to be very clearly defined. It has to be very smart, depending upon what sort of documents that you are currently working on. You can implement your chunking size. The second one is the low quality embeddings. We have used all mini LM L6v2. It does work, it does the job, but it is not the state of the art model. There are many different models out there. The text embedding model from OpenAI, of course, that is a really powerful one. You can deploy it in Azure OpenAI, and then you can play it. You can deploy it in Azure AI Foundry, and you can play around with it. It is such a good model. And there are many other good models from Databricks and from Mistral and from Llama also. You can play around with all those different models. You can get them from Hugging Face also. Third one is the metadata gaps. So capturing the metadata, like who is the author, when was this file created, all these are very important. Because let's say if you're dealing with a file, there might be 4 different variations of this file, each created in different months. Name of the file is exactly the same, but the latest information is present only in the last file. Now, whenever you're chunking, your pipeline might retrieve chunk from previous versions, which is going to give you inaccurate information. So there's no point of building a RAG if you're still getting inaccurate information, right? So you need to make sure that whatever metadata you have is being captured properly. And also all of that metadata is being used properly for filtering and retrieving. Next is the context window overflow. So in the very first module for AI basics, during AI basics, I've explained what is context, text context token length. And let's assume if it is 50,000 tokens, if you are fetching top 3 results, each result itself is taking up 50,000 tokens, then your pipeline is not going to work, right? Your LLM will not be able to answer anything. So you need to make sure that whatever you are building, wait a second, what up? Yeah, so you need to make sure that whatever you are building, it has to fit within the context token length. You can either increase your context token window size in AI Foundry, or you can reduce your chunk sizes, or you can play around with your top N or top K value. Next problem is hallucination. So let's say if you're fetching too much of information or too little information or wrong chunks, that is also going to lead you to hallucination again. So in the past, I've already explained you what is hallucination, what are the different types of hallucination that you'll face. You will be facing the same issues again. Finally, we have outdated knowledge. So in outdated knowledge, we need to make sure that whatever embeddings we have in the vector database are up to date. So let's say if you have created a vector database today, after 1 month or so, all of your files will be updated, right? L&T website is not going to remain the same way forever. So you need to constantly keep on updating these embeddings. Uh, how are you going to identify which embedding to update? With the help of ID. So we have vector ID, right? Embedding ID. While inserting, we are going to use these IDs. We have to use the same ID to overwrite any of the previous documents with the latest ones. This applies mostly for the all sort of knowledge bases, but this applies especially for databases which are heavily built on files like SharePoint and Confluence, etc. And of course the chatbots. So access control leakage. So let's suppose if there are certain things written in HR documentation, for example, what are the different process in which you can give appraisals, how much appraisal to give for which employee, all this information, if you're storing it in the vector database, and if I'm able to access all of that, even though I'm not a HR, that is a problem, right? I should not be able to access all those information. So while building the RAG, before querying, you need to filter out your collection to make sure that you are excluding all the embeddings for which I should not have access. This is one of the most important factor that you have to keep in mind. And if you're judging somebody's RAG architecture, this will definitely help you to understand how robust they have built, how many different situations they have considered while building it. Finally, latency issues. Nobody likes to wait. LLMs are pretty fast, but if your retrieval function is not fast enough, then the overall experience is going to be very, very slow, and that's going to give you a very bad impression. So you need to make sure that the latency is very slow. And the data format mismatch, the most stupidest thing that you can imagine. If you're getting output in one format and if you're sending it to the LLM model in a different format, then it's on you, buddy. So if you take this example, if you're getting the output in SQL query, and if you're passing it in the form of a paragraph, if you're converting the table output into paragraph and sending it to an LLM, that is bad because LLMs are really good at handling JSON schema. They're really good at handling tabular schema, markdown tables. So convert your data frame into markdown table or convert your data frame into JSON format and then send it to the LLM model. If you are converting everything into a string and then passing it to the LLM, then you can expect some really bad results, inaccurate outputs. Finally, we have embedding drift, which is slightly, how to say, rare, but this is also something that you have to consider. So let's suppose mismatch between sorted embeddings and queried embeddings. So in the example that we have built just now, we have used the, I forgot the name of the function. Cross encoder. Yeah. So we have used this cross encoder. But sometimes what happens is if your embedding model and your cross encoding, the re-ranking model are not in proper tune, then the chances are it will get rid of chunks which might contain the actual information that you're looking for. To avoid those kind of situations, we need to make sure that your embedding model and your re-ranking, not just model, you can do the re-ranking in many other ways also. You can use fuzzy matching or difflip or many other techniques. So whatever technique you're using for re-ranking, you need to make sure that it doesn't get rid of important information. So these are some of the things that you have to keep in mind if you want to improve your RAG properly. Now, let's see what are the different problems that you face when you're going to build application specific projects. First one is file based knowledge assistant. SharePoint files, Confluence files, etc., etc. So whenever you are working with, or even local file uploads, also, if you are uploading something to ChatGPT, that is also a knowledge base, file based knowledge assistant, right? The very first problem that you'll face is OCR errors. If the scanning is not clear, if the handwriting is very, very ugly, if the PDF is very much blurred out, then you are going to get some really noisy text. It will not be able to read the text properly. Now, if you don't have a proper backend for reading tables, graphs, images, then you're going to lose information, right? If you have a whole bunch of tables, everything inside of your PDF is just tables, then you cannot ask any question. You cannot do anything with that PDF because everything is in text format and you're not able to use all of the tables. Sorry, everything is in table format and you're not able to use those tables. Okay. Next is NLP to SQL chatbot. The very first step is to write SQL query, get the results, then use them as the relevant content. But the very first problem that you'll face is if the query itself is not correct, if it hallucinates and creates its own column names, its own table names, which don't even exist in your database, then you're going to face a problem. You'll get some error messages and you'll not be able to retrieve any relevant data. So whatever schema that you're passing, you need to make sure that your LLM is able to write the queries as per the schema properly. Next, when you're working with SharePoint chatbots, you will face the permission issues. So let's say you need to make sure that you configure the permissions properly because I should not have access to the HR related documents. At the same time, somebody else should not have access to some other department's documents. So we need to make sure that this permission is set up properly. Second important part is the API rate limit. So if you are parsing everything from SharePoint, it has a limit for how many times you can read, how many documents you can read per day, per month, per year. So you need to make sure that you are capturing everything within that limit. If you are exceeding that limit, then you will not be able to read the documents properly. This is one more problem that you will face. The same thing goes for Jira and Asana also. So sometimes you might not have enough information and sometimes you might have too much of information, so status and priority levels, they might be missing, they might not have entered that information. But if you take a look at comments part, one ticket might have like 5,000, 6,000 comment, not 5,000, it's way too much, but maybe 100, 200 comments from different people. So that is going to cause a lot of hallucination again. So we need to make sure that that part is also addressed where you take only the top comments, top relevant comments. These are some of the application specific problems that you'll face whenever you are building a RAG backend. With that, we have completed the course on RAG modules. Next, we are going to learn about agentic AI. Thank you so much for watching. See you in the next video.